Aye, aye, matey, here we go. Lesson 4.5, Systems of Linear Inequalities. Arr! If you have a system of linear inequalities, it's a set of two or more linear inequalities in the same variable. Here's an example, inequality 1, inequality 2. When we're talking about the solution of a system of linear inequalities in two variables, it's an ordered pair that is a solution of each in the system. Arr! So let's see what that looks like. All right, if you can recall the graph of a system of linear inequalities, when we graphed them, we shaded in half the plane that included the solutions. When you graph the system, you'll have two parts that are shaded. The part that they overlap, the intersection of the graph, is where we find the solution. So if you're using colored pencils, if you want to use a pink and a blue, the purple part will contain all the solutions. Any ordered pairs that fall into the purple part would be a solution to the system. No longer is it just the point, and sometimes it may not be the point because where these 2 points intersect on the dashed line, remember, the dashed line means it is not part of the solution. So that may not be the solution, just like it was when we were doing just regular linear systems. So let's try to do some of these. In the first example from your book, we're going to tell whether the ordered pair is a solution of the system. Arr! So here's the system. Y is less than 2x, and y is greater than or equal x plus 1. We're checking to see if 3, 5 is a solution. So all you do is substitute it in. So it works for this one because 5 is less than 6 is true. For inequality 2, 5 greater than or equal to 4 is true. So we can say that 3, 5 is a solution to both. Looking at negative 2, 0, when you substitute in these values, you get 0 is less than negative 4, which it is not, so it doesn't work for that one. But 0 being greater than or equal to negative 1. But if it's not for both, then we cannot say that it is a solution to the system. It has to be a solution to both. Arr! Catch my drift? All right, so let's tell if the system, or if the ordered pair here, negative 1, 5, is a solution to the system. So we'll substitute this in. So for instead of y, we'll put a 5. 5 is less than 5. Is 5 less than 5? No. Let's try it here. 5 is greater than negative 1 minus 4, which makes 5 greater than negative 5. No. So the answer is no, it is not a solution. Over here, 0 and negative 1. So negative 1 less than or equal to negative 2 times 0 plus 5. So negative 1 is less than or equal to 5. Yes, it is. We also have negative 1 is less than 0 plus 3, which makes negative 1 less than 3. And again, yes, it is. So this ordered pair is a solution to this system. Arr! Going to clear the screen. Okay, so let's go ahead and practice graphing some. So we're going to get, to practice how we graphed these in our last chapter, remembering that we used, let's see, I'm going to get a pen here. We had for the less than or equal to, greater than or equal to, we use a solid line, because these mean that numbers that are on the line are included in the solution set. For less than or greater than, we use a dashed line. Not, these numbers on these are not included. Okay, so it looks like for number 3, we're going to be using a solid line for both. So let's go ahead, start with the first one. We have one. It's hard to do with one eye. 1, 2, 3, 4. All right, and then it is a negative 1 slope. guess I could just be doing like little dashes through that, right? Because that's what it's kind of doing. We're not doing a straight line, we're doing little dashes. Well, we're actually not doing dashes, we're doing a solid line. I forgot, sorry. Just got done saying that. Oh my Lord, okay. Okay. All right, here we go. Then let's check 0, 0. Is 0 greater than, if this was 0, 4? Is 0 great? No, it is not. So we will shade this way. Okay, switching to a different color here. I'm going to go ahead and put this in slope-intercept form. I'm going to get y is less than or equal to negative x. All right, so I have a point here, and then this negative slope. And what can you tell about these lines now that I've put them into slope-intercept form? They are parallel. But let's see if there's an overlap, right? Because if I shade this way, I could be shading in over the blue and get a solution, right? Oh, almost. Oh, almost a perfect line. Okay. Well, let's try it. We can't use 0, 0, but let's use, say, 1, 1. So if I put in a 1 here, 1. So is 1 less than or equal to negative 1? No, it is not. So that means that this point is not shaded, and I will be shading this way, which means there is no overlap, okay? And there is no overlap for the solutions. So on this particular one, we would indeed have no solution. So just because they are parallel, the only reason that there's no solution is because they're not shaded in the same direction, all right? If they overlap, those would be all the solution points, so keep that in mind. Okay, looking at number 4. All right, this is going to be a dashed line. This is going to be a solid line. So negative 3. This is my dashed line. Okay. And then I will switch colors here. Let's do pink this time because it's fun. I'll start at positive 1, and I'm up 1 over 2, 1 over 2, 1 over 2. Okay, down 1, back 2. I forgot to shade in the blue line. We need to go back. Oop, oop, oop. I forgot to go 2, didn't I? Down 1, back 2. Let's get rid of this silly little line. All right, so I'll draw this line, and it's a solid line. Okay, let's just go ahead and test 0. Is 0 greater than or equal to 1? No. So I want to shade above here. Okay. Let's go back to the blue so we can shade in the blue. Okay, so let's go ahead and test 0, 0 here. So is 0 greater than or equal to -3? Yes, it is. So I'm also going to shade in here. So I'm going to oh, look what I did there. How can I go and hit an undo button? Is there an undo button? Oh man, just have to erase it. Okay, I'll erase. Sorry about that. My bad, my bad, my bad. Okay, so I'll go back to the pen. Got a little crazy there with, so I'm shading in the blue only, okay? All right, then remember my pink went above the pink line. Okay, so it's the purple, and where would the purple fall? The purple's gonna fall for the blue, like here, this will be purple, this will be purple, this will be purple, this will be purple, this will be purple. You know, everything over here is going to be purple, right? Right? But this part right here is just gonna be pink. This part right here is just gonna be blue. So again, it works much better on paper when you're actually using colored pencils. Arr. Okay, sorry about that. All right, I'm gonna go back and switch to blue. I'm gonna go ahead and put this in the right order. So we're gonna have y is less than 2x plus 4. I'll go ahead and do the pink here. We're gonna subtract 2x. So y is greater than negative 2x plus 4. Okay. I'm going to move me maybe right there so you can still see that part. We're going to do dashed lines on both this time. So the purple part is the solution. I could pick any point, right? I could just say like, 1, 2, 3, 4, 2, 4, 2 is a negative 4, 2 is a solution, and it would satisfy both, and then I could try it out. That would be a way to identify at least one of those solutions, but usually just the place that they're both shaded is fine. All right, so I'm going to go back over here to number 5. I'm working on the pink line. All right. I will probably have a headache after making this video. Trying to look out of one eye. Arr! Can't believe I'm doing this. I will live to regret it. All right. So we have this dashed line here. Dashed lines are easier than the solid lines. All right. Now, 0, 0 is not part of it. So is 0 greater than 4? No. So that part is not shaded. So, okay, this part is. Okay. Switching to blue. All right, again at 4. And now it's up to 1. Well, I just colored over everything. Okay. R. Okay, we'll just go from here. Another dashed line, right? And we'll just kind of follow it along. Very good. Very good. Okay, let's try 0, 0. Is 0 less than 4? Yes. So that means I'm going to shade in below, and look where it is purple, all along here. So this becomes the purple area, all in here on both sides. Okay, so I'm making it very exaggerated purple. Okay, and so I could pick any point, right? I could come over here and try a point and say 1, 2, 3, 1. Let's try 3, 3. Can I make that 3, 3? Okay, let's try the pair 3, 3. So if I have, it should make it true, 2 times 3 plus 4. Is 3 less than 10? Yes. Is 3 greater than, so if we have negative 6 plus 4, we have 3 that is greater than negative 2. And again, also true. So notice that the solution I picked in the purple part, I just randomly picked a number, and I don't even know if it's really 3, 3, but I just kind of looked at that and said, okay, that's got to be 3, 3. It's in purple, is a solution to both. Any of the points over here will work for both. Okay? Getting ready to clear. Arr. So mark down all your work, or you'll walk the plank, matey. Okay. Guess what? We're going to go ahead and skip this for you, save time. All right, next up, we are going to write a system of linear inequations. So again, when you have this is the solid line, so we can help with the symbols. This is the dashed. All right, so first we're gonna try to write these as if they are just a regular linear equation, okay? And then we'll put in the symbol based on the shading. Now, the part that they shaded is only the solution, only the part that is the solution to both. So imagine the part that is shaded is actually the purple part, okay? It's like they got rid of all the rest, all right? So let's start with this vertical line. So the vertical line is gonna be x kind of equal to 3, right? But it's a dashed line, so we know that it's going to be like less than or greater than, but it is shaded left of that. So it is going to be x is less than 3, right? Because 2 is less than 3, 1 is less than 3, and so forth. And we know that 0 is less than 3. So that's our dashed vertical line. Okay, then looking at this one, okay, we have a y-intercept of 2, and it looks like a slope of negative 1. So y is negative x plus 2. Again, okay, 0, 0 is shaded in, so it's a solution. So if you have 0 blank 2, what is 0? 0 is less than 2. So you can always kind of test it out that way, knowing whether or not 0 is shaded in or not, okay? But it's also to the left of that or less than that line. So that's how you could get those, if that makes sense. Okay, here we have two solid lines. So we know we're going to be working with greater than and equal to, less than and equal to. So first, let's look at this line. We're going to do a y-intercept of 1, and then the slope is down 1 over 2, down 1 over 2. So it's like a negative 1/2. So y with a negative 1/2 x plus 1. All right, now it's shaded above that. So my guess is greater than or equal to. So if I have 0 and I have 1, let's see, here, I'd have, it's not true, right? So this is greater than or equal to, because if I put 0 and 1 on this side, 0 is not greater than or equal to 1 and shouldn't be shaded in, and it's not, because that would be below the line that we just calculated. So that's how we know it's above. Okay, next line right here. It looks like it's crossing at -3, and it has a slope of 2, positive 2. So slope of 2x minus 3, because it crossed at -3. Okay, it looks like it's kind of being to the left. So let's see. If we substitute it in 0, is 0 greater than -3? It is. So it can't be greater than, because otherwise this would be shaded in over here. So it has to be less than or equal to, and kind of it's going down, or less than the y values, I guess. And 0 less than or equal to -3 is not true, and the point 0, 0 is not shaded in. So that's how you can verify that you did it correctly. Arr. Okay, so I'm going to go ahead and clear it out, and I want you to go ahead and make sure you have everything written down. All right, here we go. Your favorite part, vocabulary and concept check. Make sure that you are putting and identifying the number, putting your answers in complete sentences. It says, friends and good manners will carry you where money won't go. Margaret Walker. Awesome. Thank you, Margaret Walker. You do not have to walk the plank. And I will see everybody else in class tomorrow. Make sure that if you have any questions, you let me know. And have a good night. Arr.